Hello everyone, my name is Thimianos and I'm glad to be part of the 15th Hellenic Astronomical Conference. I'm going to talk to you about the substorm activity and the electron flux in the outer Van Allen belt. We're looking to find the correlation for the substorm activity which have been studied extensively so that we can correlate them with the electron flux in the outer Van Allen belt and gain a broader knowledge of the phenomena to help us with the prediction of the space weather. We studied a total of 236 phenomena in the years 2016 to 2018 and compare source and seed electron flux data from the MAGAIS instrument with the magnetic activity on Earth. For the selection of the event, we use the Super Mag-Electrojet Index, which is in complete identification with the AE index, but it shows a global occupancy with more than 100 magnetometers around the world. We set the time frame for the substorm event and we calculate the flux ratio of each event. Every event has at least 2 hours of quiet magnetic activity before it starts, and the satellites must be in the outer Van Allen belt and inside the night side magnetosphere. The threshold that we used is calculated by the mean of the SME index for the 3 years plus the STD value. When the index crosses the threshold, we have a substorm event until it comes back down after the event finishes. This is an example of a magnetic substorm activity. We will observe the flux ratio to SME index plots for all events and compare the results with the same plots using only strong and weak events. We compare the size of each event with the mean of the SME index and categorize them accordingly. Also, we are going to use events that shows a decrease and increase in the flux ratio as so. Due to lack of time, we will only present data for source and seed electrons and for satellite RBSPB only. We can see that the correlation coefficient for the total of 236 phenomena is below 0.5 for every channel in the source electrons population, and we can see a small improvement during the separation of the substorm size. More specific, we can see an anti-correlation in channel 6 and 7 of the strong events, and we can see a better correlation at channel 5 to 7 for the weak events as well. The correlation coefficient of the seed electrons are even lower for the total of 236 phenomena, and again we have a small improvement during the separation of the strong and weak events. Again, anti-correlation with the strong events, and again a better correlation for the weak events as well. Regarding the flux ratio of the source events, we can see that again the correlation coefficient is below 0.5 for every channel, and the events that shows a decrease were only a few, and we were not able to calculate the correlation coefficient for these channels. For the events that shows a ratio increase in the electron flux, we have a small improvement in the correlation coefficient at channel 6 and 7. The seed electron population follow the same path, and we can see a small improvement of the correlation coefficient in the middle energy around 200 kV. To sum up, the best correlation coefficient between the SME index and the flux ratio appear with the seed population as we expected. Unlike we expected, we saw that more than half of the events showed the flux increase. Although we expected to see 50% increase and 50% decrease in the flux, we had almost 70% increase and 30% decrease. In total, the correlation coefficient of this study are low for every channel, and they do not reflect a good correlation as we know it. This happens because the years of the events are located in the declining phase of the 24th solar cycle, and maybe the quiet sun affects our results. Thank you for your time and consideration. Available for questions at any time.